Okay, let's get started with making your first 2D game from the Godot documentation. The first thing you're going to need to do is scroll down to the prerequisites section and then make sure you download the Dodge the Creeps 2D assets .zip file. With Godot open, let's go ahead and set up our project. You're going to click on Create New Project, call it Dodge the Creeps 2D. / is fine, whatever your project path is. I'm not really going to use Git and we will edit it now. Click Create. This game is designed to be in portrait mode, so let's go ahead and get that fixed right now. Go to Project, Project Settings, go down to Display Window, and we're going to change the width to 480 and the height to 720. Before you close it, go down to where it says Stretch, and we're going to change the stretch mode to Canvas Items and aspect ratio of Keep. This will make sure that the game scales correctly even if your monitor is a different resolution. Let's go ahead and set up the player scene now. We're going to click Other Node and start typing in Area 2D. Double click that. I'm going to left click on this, and then from here we can just start typing Player. Use a capital P for this one, and then go over here to where it says Group Selected Nodes and left click on that. You can also do Control G. What this does is if you were to select any of the child nodes that we'll be adding in the future, it will select this top root node. Then let's save this scene. So I'm just going to hit Control S and we'll call it player.tscene, and right here is fine. Now for the animations, let's select our player node, right click it, go to Add Child Node. Let's type in Animated Sprite 2D, create. We're going to get more warnings, but don't worry, we'll take care of that. With this Animated Sprite 2D selected, go over to the right, and where it says Sprite Frames, we're going to click on this, and we're going to create a new Sprite Frames resource. We'll click on this to open the Sprite Frames animation doc. Then click on where it says Default, and let's just rename this to Walk. And then left click on this Add Animation. You can also hit Control N, and we're going to call this one Up. Now with this up animation selected, you're going to open up these resources, and then where it says player gray up 1, you can just go ahead and click and drag that out here. That'll be our first frame. Then player gray up 2 right next to that. Let's do the same for the walking animation. So left click on walk, walk 1, walk 2. That's it. Now, because these are too large, we need to scale them down. Make sure that your animated sprite 2D is selected, not the player node. Go to the right to transform. Where it says scale, we're going to type in 0.5. Now they're half as large. And finally, we're going to add a collision shape 2D. So left click on player, to add a node. It's going to be a collision shape 2D. I'm going to hit enter. We'll add it right there. Look over to the right with it selected. We're going to give it a shape. So for the shape, let's use a capsule shape 2D right there. Now we have a shape and our warnings are gone. With this collision shape 2D node selected, let's zoom in, make sure it's selected, and let's resize this so that it kind of fits our guy. With that out of the way, make sure that you save the scene. All right, let's start getting our movements set up. Go ahead and right click on the base root node and then click on attach script. I have a little shortcut that does this for me, which you'll probably see me use in the future. This will inherit from Area 2D. We're going to use the default template. Don't use the built-in script. Path is fine. Hit create. Now we need our member variables. So from right here, and I will explain pretty much everything you see. I'm going to hit Control Shift Enter to make a line below me. We're going to type in @export bar speed is equal to 400, and this is how fast the player will move in pixels per second. So if you haven't seen an export variable before, because we haven't used them in the rest of the documentation, this allows us to edit variables that are within scripts from the editor. So if you look over to the right, you'll see the speed that we have set is right here. And if you were to write this in, if you were to write 300, this will overwrite what we have in the script. I'm just going to put that back to the default. And then our next variable is just going to be screen size, screen_size, and save. Now we need to get the screen size, and this will be important in a moment. So the variable is going to be called screen size is equal to get viewport rect. I'm going to type it all out as one line and then hit enter. Type .size so we can take the size property from this. So as you can see, we defined screen size over here at the top. It's one of the member variables of our player.gd class. What it's doing, it's taking the viewport rect, which would be basically our resolution for now, and then it's going to get the size and it's going to assign that to the screen size variable. Now we need to set up the actual keys we're going to be using for it. So go to project settings, input map. Now let's start by adding our move to the right where it says add new action. Start typing in move_right. You can hit enter. Hit the plus sign. And from here, I'm just going to hit the right key on my keyboard. It's automatically going to put that in there. Hit OK. And then we'll do the same for move left, up, and down. Let me just do that quickly. And when you're done, it should look just like this. Let's close this. We'll be handling input for this little project within the process function. This isn't always the best way to do it, but this is what we'll be doing. Go ahead and highlight pass here within the process function, and then let's start making our variables. So var velocity is equal to vector2 dot 0. This would be just a vector 2. It looks like this. And this will be the player's movement vector. Now we'll set up the case for if we are moving to the right. So go ahead and type in if input dot is action pressed, enter. And then you can use the down or up arrow to go ahead and select move right, or you can type it in semicolon velocity dot x is plus or equal to 1. Input is a singleton you can call from almost anywhere, and on that singleton we're going to call its isActionPress method. This returns a Boolean value, so true or false, if we are pressing the move right key on our keyboard. And if that is all true, then it's going to take the velocity of this node, the player node, its x position, which would be this one, and it's going to take that value and it's going to add 1 to it, to wherever it currently is. This will cause you to move to the right, as you can see. Back in our script, I'm going to go ahead and fill in the rest of this. Now your input should look like this, and hopefully this makes sense to you. Moving right is your x transform to the right, your x position to the right. The left be to the left if it's negative. Now in a 2D coordinate plane, 1 is a positive direction. This is negative. This is a negative y in this area above your screen. To show you real quick in case it doesn't make sense. So as this increases, you go downwards. And as it decreases negatively, it goes upwards. Reset that. I forgot to mention a little bit earlier, but if our velocity vector is 0, which is what it's set to at default, it means we're not moving. Now we need to normalize our movement. I'll type out the code first and then I'll explain it. So if velocity.length is greater than 0, take our velocity and assign it a normalized value like this. Velocity dot normalized times speed, the speed variable being what we set over here at the top, and which we can edit from the editor. So what you need to know is that a normalized value just makes it have a maximum of 1. So from 0 to 1 usually. And that is important for this reason. If you ever play some 2D games, you may notice that you move faster when you move diagonally. Secret of Evermore is one of these games where, for example, if you press up and right at the same time, you would move faster diagonally upright. Here's a little reasoning why, because I think it is kind of important to know if you're going to make 2D games especially. So let's say we have a vector of 0, -1. From the origin point, this would be going up like that. And then let's say we have a vector of 1, 0. This is a vector going to the right. Now, because a vector is a direction and a magnitude at the same time, let's say you're pressing both of these at the same time, that's going to give you one of these. It's going to give you 1, -1. So the value of that. Now, as I understand it, for example, if you're going up, the magnitude of this is 1. It's taking the absolute value of that. The magnitude of this direction is also 1. However, because of this length and because of the way we do vector math, the length of this is actually going to be something like 1.141. So you are moving faster diagonally, and this is from the Pythagorean theorem. So it's your, 1 squared plus 1 squared, and take the square root of that. And with that, we're going to take the square root of 2, and this will give you the 1.141. That is greater than 1, so you will move faster going diagonally. Hopefully that made sense. This is my first time giving a little math tidbit in my tutorials. And because that's the case, as long as we normalize this, or we set it to have a maximum of 1, or basically be between the numbers 0 and 1, this will be a 1, and you'll move at the same speed diagonally as you would up or to the right. Now then, if the player is moving, we need to start their animation. So with that, we're going to do $animated sprite 2D, I'm going to let it autocomplete, .play. And if they're not moving, let's stop their animation. So $animated sprite 2D stop. Let me explain this one. So this $animated sprite 2D is not the best way to get a reference to a node, but it is how we're going to do it in the documentation for now. It's pretty simple, easy to explain. So with this $sign followed by the node name, we can access it and we can access its properties. So animated sprite 2Ds, we hold control and left click on display. They have a play function right here. Belongs to the animated sprite 2D class. And we can access that very easily just by doing that. Same with the stop. Now we need to restrict movement to the screen itself. So from here, let's type in position is plus or equal to velocity times delta. Position has to be equal to position dot clamp. Within that, let's use a vector 2 set to 0 like that. And the second parameter needs to be screen size. Position here is the same as the position here under the transform for our player node 2D. What clamp does is it takes in 2 parameters. The one on the left will be the minimum. The one on the right will be the maximum. Vector 2.0 is 0, 0. This corresponds to the very top left of the screen. whereas screen size corresponds to the bottom rightmost part of the screen. So right here. So in essence, what this is doing is it prevents our player from going farther to the left than our screen size, or up, or to the right, or down. So we're constrained within this due to the position. And with that taken care of, our player movement should work now. So then I'm going to hit F6 on the keyboard, and there's our little alien. So cute, so precious. Now you're going to notice that moving to the right, everything looks okay. Moving up, everything's okay. But when we move left, we're supposed to be flipped facing the left. And when we move down, we should be flipped entirely. So let's go ahead and fix that. Now then, on a new line that is in line with all of these other if-else statements, we'll start typing a new one. So if our velocity on the X coordinate is not equal to 0, take our animated sprite 2D, which we've been using, and set its animation property to walk. We do that again. Animated sprite 2D dot flip v is equal to false. We do the same thing by doing $animated sprite 2D dot flip h is equal to our velocity dot x greater than 0, and I will explain this in a moment. If that's not happening, do an else if velocity dot y is not equal to 0, and once again animated sprite 2D dot animation is equal to up, and our animated sprite 2D dot flip v is equal to velocity dot y greater than 0. If we are moving horizontally, make sure the animation is set to walk. Or moving vertically, make sure the animation is using the up or down animations. What the flip V here is doing is, let's say we're moving horizontally, we don't want to be upside down. That doesn't really make sense. So we're going to make sure that it's set to false. However, over here, the velocity.y, if that's greater than 0, it means we're going downwards. And so we need to be flipped vertically so that this guy will look correct. This actually resolves to a Boolean value of true or false, and then that sets flip v. Similarly here, if velocity.x is less than 0, that means we're moving to the left. And if we are moving to the left, we need to flip h, or flip our sprite horizontally. That becomes true. It's true that we are moving to the left, therefore flip our sprite horizontally. So if we go down, we're flipped. We go up, we're not. We go to the left, we look to the left. We're now flipped horizontally. And if we're moving to the right, we're not flipped horizontally. It's false. And so we continue moving to the right. We're going to manually place our player in the scene. So under the ready function, go ahead and type in hide right here, just like that. Now we need to get ready for collisions. So above your variables, but below where it says extends area 2D, I'm gonna hit enter, control shift enter, and then let's type in signal hit to start defining our new hit signal. This is the signal we're gonna use if we are hit. With the player node selected, go up to node. We're going to go to where it says body entered. Left click that, hit connect, and we are going to make a new function. We're going to make a new receiver method with this. Click connect, appear right here at the bottom. We can confirm this has been connected properly. If we left click on this, you see the source is the player node, the signal is the body entered signal, and the target is the player. Let's get this working now. So if we're hit, we're going to hide the player, they disappear, and then we're going to emit that hit signal that we created earlier. Now this next line is important. Let's get a reference to the collision shape 2D node that we have over here, and on that we're going to call set deferred, and then disabled is true. Now then what this set deferred method is doing, well, you can see it there, but what it's doing is it's taking the disabled property on that collision shape 2D node and it's setting it to true. So the first parameter it takes is the property, and the second one is what you want to change it to. Because disabling the area's collision shape can cause an error if it happens in the middle of the engine's collision processing. Using set deferred tells Godot to wait to disable the shape until it's safe to do so. And then we need to define a function that we can call to reset the player when starting a new game. So right here at the very end, start defining it with func. Start, it's going to take in a position, semicolon. With that position, let's set that equal to POS, and then show the character. Go ahead and get its collision shape 2D, and disabled is now equal to false. So this is the function that we'll use to start the game basically and to set up where the player is at the start. Let's get started with making our enemies, and for that we'll need a new scene. So over here next to player, go ahead and hit this plus sign to add a new scene. For this we'll need a rigid body 2D, so click on other node and then start typing in rigid body 2D, hit enter. Go ahead and rename this one to mob, hit enter, and then let's start adding in our animated sprite 2D. Make sure that these are all children of mob, collision shape 2D, and then visible on screen notifier 2D. So it should be set up just like this. From here, hit Control S to save it, and we'll just save it right here, although this isn't best practice. Go into the 2D, and with mob selected, hit Control G so we can lock this. Mob selected, go into the inspector, and set your gravity scale to 0. This will keep the enemies from just falling downwards when you start the game. Look to the right, and where it says Collision Object 2D, go ahead and open up Collision and uncheck 1 on the mask. This prevents the enemies from running into each other. Now for the animations, click on Animated Sprite 2D. We'll need an Animated Sprite 2D resource called the Sprite Frames right here. Make that. I'll get rid of the warning. After you left click on it, we're going to set this up the same way we did the other one, so please refer to that. I'm going to go ahead and set mine up now. When you do it, make sure you have a fly, swim, and walk animation set. This corresponds to each of these PNGs in our resources folder. When you're done, yours should be set up just like this: fly, swim, and walk. These do need to repeat, they do need to loop, and for each of them, make sure the FPS is set to 3, just like this. Just like with the player, we will need to scale these animations down. So go over to Node 2D, transform, and set the scale to 0.75, like that. Now for the collision, left click on Collision Shape 2D, hit F, it'll center over your node. For the shape, let's go ahead and use a Capsule Shape 2D as well. We will need to rotate this so that it fits properly. So under our Node 2D properties, under Transform, set the rotation to 90 degrees. And we can just drag this out. Like so. Make sure you save this so you don't lose it. And then to our main node, let's go ahead and add a script. All of these settings are fine. Let's hit create. From here, let's go ahead and get our animation set up. So let's replace pass with a variable that we define known as mob types, which is equal to an array. Within that, we need to take our animated sprite 2D, get its sprite frames, and get the animation names. You're going to have to type this one out. .get underscore animation underscore names. That's it for that line. On the next line, do animated sprite 2D dot animation is equal to our mob types dot pick random. Then with our animated sprite 2D, play the animation. So this should be pretty straightforward, these two lines. However, this one I'll quickly go over. So within the animated sprite 2D, let's look at its sprite frames. What this is doing is it's just getting the animation names for all of the animations that it has in the form of an array. So that's all this is looking like. It's just fly, swim, and walk in an array. And then it's assigning that array to the mob types. Because mob types is an array, Godot allows you to use the pick random method on that, and that just randomly picks something out of the array, which could be any of these animations. We want these enemies to delete themselves when they leave the screen, and for that we're going to use a signal. To do that, make sure you have your visible on-screen notifier 2D selected, and then go to the Node tab. Under Signals, we're going to select Screen Exited. Hit Connect. Go ahead and connect that right here. And within that new method, place pass with queue free. What this does is it deletes it as soon as it leaves the screen. And that's it for your enemy. And now we need to bring everything together in our main game scene. So to do that, go ahead and click this plus sign. Going to make a new scene. Click on other node, and we're just going to make the most basic node right here. Hit create. We're doing this because we don't really need all the special functionality of everything else, because this node is going to contain all of our game logic. Open up the 2D workspace, go to the center if you want to see this. Right click and do instantiate child scene. I have a shortcut for Control-Shift-A to do this quicker. Now select your player scene. This is going to instance your player scene within your main scene, which we're about to do. So let's go ahead and rename this to main. Save that, save it as main. Now we're going to add some nodes to this main one, mainly timers. So from here, I'm going to hit Control-A, the timer node right there, and we can duplicate this. Control-D again. And now we need to add a marker 2D. This first timer needs to be named mob timer, just like that with Pascal case. Score timer on the second one, and then start timer on the third one. The marker 2D needs to be named start position. Now let's edit those timers directly. In the inspector, go ahead and click on mob timer and set its wait time to 0.5 seconds. On score timer, make sure that's set to 1. And then for start timer, set that to 2. Under start timer, make sure one shot is set to on. And then for the start position node, select that, go under transform and set its position to 240, 450. That's where the player is going to start. Let's get our mob path set up. So click on the main node here and then Control A. And then we're going to use a path 2D. Go ahead and add that. We're going to name it mob path. This will add some new buttons to our editor. Let's temporarily hide the player. For this, I'll be using the Smart Snap as well as the Grid Snap. Then click on this middle button for Add Point. we're going to have a point right here. Left click there, and make sure you do it in this order. Left click there, then there. And then after you do this fourth point, come up here and then hit close curves like that. With that set up, we're going to add a path follow 2D node right here. That's going to be a child of our mob path. Create that. And then we're going to rename it mob spawn location. Make sure that your scene tree looks like this before you move on. Click on it. We're going to add a script to it. This should all be fine. Go ahead and click on create. For this, we're going to do @export var mob scene act scene var score. What this lets us do is go over to the editor, do load, quick load. We're going to select the mob that we're going to do. Now later on, whenever we refer to this mob scene, it will be this mob that we've created before. And that'll let us spawn them in. Go ahead and left click on player over here in the scene tree. And then we're going to go to node because we're about to use a signal. Double click on the hit signal that we made before. Instead of allowing it to use this default name, we're going to call it game over. So when we get hit, the game ends basically. Hit connect. So when we get hit and the game ends, let's highlight this pass, type in score timer dot stop to stop that timer, then mob timer dot stop that timer as well. Let's save it. So if it's not clear, the game over method is really the receiver method created by the hit signal. So when the players hit, they will emit that signal and then the game over functions will run. In addition to that, we need a new game function. So you'll type in func, new game. We'll have a variable named score, which is equal to 0. Let's access the player node, then start position is position. And then the start timer also needs to start. What this is doing, it's taking the position of our start position node, which if you recall is over here, right there. So it's taking that position and then within the script, it's passing it to the player's start method. And if you recall way back here, it's right here. It's taking the position, it's passing it in here. It's setting the position of this player node to that position, and then it's showing the character. And now their collision shape 2D is enabled. And it's enabled even though it says disabled false here, because if something disabled is not disabled, it becomes enabled. So back to the main script. Now we need to set up the logic for each of these timers. So you're going to select, for example, a mob timer first. Node, signals is fine. We need its timeout signal. Hit connect. We are connecting to the main script. Receiver method name is fine. We're going to use the default names for all three of these. So let me repeat that process like this. So yours should now look just like mine. Let's do the onScore timer timeout function first. So when that times out, our score will increase by 1. Then in the onStart timer timeout, this is what's actually going to start the other timers. So let's get a reference to mob timer and start it. Let's also get a reference to score timer and start it. Now for our on mob timer timeout, this one's going to be a little bit more complicated, but let's get through it. So this one is going to create a new instance of the mob scene. Var mob is equal to mob scene dot instantiate. If you remember back in the inspector for this main node, our mob scene is set to a pack scene of this mob. So this entire mob, it's not really spawning it in quite yet, but it is instantiating it. But we'll get into that in a moment. So next up, we need to choose a random location on path 2D. For this, let's make a new variable, mob spawn location. And that is now equal to mob path / mob spawn location. I'll hit enter to autocomplete. So that's getting our mob spawn location, which we defined earlier. Mob spawn location dot progress ratio is equal to a rand f, which is a float. Now what this is doing is it's going back here, looking at this and picking a random progress ratio, which is basically a percent of how far along it is. It just picks randomly along here, and that's where it'll spawn. Then we need to set the mob's position to the random location. So mob position is now equal to mob spawn location dot position. So wherever that is on the curve will now become the mob's position. Next thing we need to do is set the mob's direction perpendicular to the path direction. Do that with var direction is equal to mob spawn location dot rotation plus I divided by 2. To explain this one, let's go back to mob spawn location. As you can see, there is a direction here. It's moving to the right and it's facing this way. So we need to know what that rotation is. Otherwise, we can't rotate the mob as it spawns. So knowing that, we then need to rotate it by pi divided by 2 radians. And what this means is that we're going to rotate it by 90 degrees to the right. This is important because as you can see, if it's moving this way, because if it's moving along this path, if it was rotated -90, it would go up and off screen. So we have to rotate it 90 degrees to the right like that, or pi divided by 2 radians. So it'll come down the screen. And this will also occur if it's on this side of the screen moving down. It'll rotate to its right and then come towards the center. Likewise, if it's moving along the bottom, and again, if it's moving along the top. So no matter what, it will always rotate to the right and come across the screen. Now with that settled, we need to add some randomness to the direction. So we take that direction that we've already defined before, which at this point would be perpendicular to the path direction, and take that direction plus or equal rand f range -pi divided by 4 and pi divided by 4. Next, mob.rotation is equal to direction. Now then, this hopefully isn't too confusing. Pi divided by 4 will come out to be about 45 degrees roughly. So it gives it a little bit of variation. And then the negative pi divided by 4 would be in the opposite direction, just so you have a little bit of a differentiated angle, but not too much, so that the mob isn't going off screen immediately again. Then with that new direction, we set that to the rotation. That's going to be the actual direction that the mob will move in. But now we need to set its speed. So let's go ahead and choose the velocity for the mob. Bar velocity is equal to vector 2 rand f range within 150.0 and 250.0. 0, 0. And then mob.linear velocity is equal to velocity dot rotated by the direction. So with this new line, as we're setting the velocity needs to be in the form of a vector 2. We don't need to worry about the y vector because we're going to be setting its rotation with this next line. However, the first one, we're going to take its velocity as being between 150 and 250 randomly as a float. That's what this does. Now we already finalized its direction over here with this code, and we're going to use that value right here to rotate it. Now then, this direction here is coming from right here. We're going to take this value that we finalized, pass it into the rotated function for velocity, and that's what's actually going to set the direction of the mob after it spawns. Specifically, this is going to get attached to its linear velocity, and that's why the y doesn't really matter, because we're setting its direction with all of this put together. So now that we have the direction and the spawn, let's go ahead and add it to the scene here with add child mob. And what this will do is it will actually create the new mob as a child of the main node. To test this out, we're going to need a ready function. So from here, type in func_ready, enter, and then go ahead and type in new game to call our new game function, which we defined right here. I'll hit F6 to start the game. And now everything's starting to kick off. The timers will go and our enemies are spawning. Everything looks pretty good. You get hit, you will die. That's it. Now we need to get our user interface set up. So for this, I'm going to go back to the 2D workspace, create a new scene, go to other node. And for this, we're going to need, as you saw, a canvas layer. We'll need a few different child nodes for this. I go here, Control A. We need a label node, Control D that one, because we need a second one. Then we're going to need a button, just like that. And then we're going to need a timer node. Let's rename these. This label is going to be score label. The second label is going to be called message. The button is going to be start button. And the timer is just called message timer. Let's go ahead and save this here. I forgot to add that for the canvas layer, we do need to rename this to HUD. Let's go ahead and save this right here. HUD is fine. Click save. Next, let's click on the score label and we're gonna go ahead and just type 0 in here. You can see this is pretty small, so we need to edit this. On the right in the inspector, go down to where it says theme overrides and click on that. Click on fonts. Here, we're gonna load in a new font. Go into your assets folder, fonts, and we're gonna use the Selenium regular. Click open. It's still too small here, so underneath font sizes, click on that, and from 16, let's increase it to 64. It's a little bit better. We have all three of those with a font size of 64 pixels and using the Selenium font. Now let's get these labels in place. So starting with the score label, select that one. Make sure for the text you put in 0. For horizontal alignment, go ahead and hit center, and for vertical alignment, also set that to center. Now then for its anchor preset, you're going to go up here and do center top. Just like that. For the message label, we're going to select that. And for its text, go ahead and add dodge the creeps. exclamation mark. Horizontal alignment and vertical alignment need to be center. Set the auto wrap mode to word, otherwise this will stay on one line. From here, go down to control, layout, transform, and set the size X to 480 so we can use the entire screen. And then choose the anchor preset of center. You can see it all coming together now. For the start button, click that, go to text, and add the text start. Now then, under control, layout, transform, set the size in X to 200 and the size in Y to 100. For the anchor preset, choose center bottom. And then under control, layout, transform, set the position Y to 580. Then for the message timer, go ahead and set the wait time to 2 seconds and set the one shot property to on. Now we need a script. I like to use my shortcut Control-Shift-Q, which I've defined myself, but if you don't have that, you can right click on that and go to attach script. This should be fine. Create it. In here, we're going to define a signal called start game. So signal start game. Let's make a little space. This will notify the main node that the button has been pressed. Now let's make a new function called show message. Now what this is going to do is it's going to temporarily display a message. Let's get access to message, which is this label right there. Change its text to text. Then show that message. Then show that message right here. And then we're going to also start the message timer at the same time. Now let's get the UI ready for what happens when you lose the game. So show game over, show message is that previously defined function. Game over. Here we're going to wait until the message timer is counted down. Await message timer dot timeout. I'll explain this await in a moment. Message.text is equal to dodge the creeps. Show the message. And now make a one-shot timer and wait for it to finish. Await get tree dot create timer 1 second and then let it time out. Start button dot show. Now what await is doing is it's waiting for a coroutine or a signal to finish and then it proceeds with the code. So that's really all that's happening here. And this create timer is just an alternative for using a timer node like here. It's just another way of putting a delay in your code, I suppose. Now we need to update the score. So let's define a new function, func update score, which takes in the score. Let's get the reference to the score label, that dot text, which is equal to score set as a string. After that, let's connect the press signal from the start button. So make sure start button is selected. Here on the right, go to node and pressed, click connect. We're going to connect that to this script. Should say on start button pressed right there. Now for the timer, we get its timeout signal. Connect that to the same script. So it should say on message timer timeout. It's like that. Now then, when the start button is pressed, we need to hide it. So get it, reference the start button and then hide it. And then we're going to emit the start game signal. That way the main node knows that the game is starting. And then on message timer timeout, let's go ahead and hide the message. So we get a reference to message and we hide it. Now that we're done with that, let's go back to the main scene here, select that, and we're going to instance the HUD scene in the main scene, just like we did with the player scene. So we're going to go here to main, right click on that, instantiate child scene, and select HUD. Now your scene tree should look exactly like mine. So now we need to connect the HUD and the main scene together. Make sure that HUD is selected. Go to the right side under node signals. We need this start game signal now. So left click on that, connect that. We're not going to use the default receiver method. So click on pick. Now within the main scene, we're going to use the new game method that we've already defined. Hit OK, then hit connect. Now if you look here, you click on this, we can see the source is coming from the HUD, the signal is the start game signal, and the target is the main, so we can verify the connection like that. Under this, we can then update it. So let's go ahead and get a reference to HUD.update score, pass in the score, HUD, show message, get ready. And then in game over, we need to also get a reference to HUD like this, and show game over. Then scroll down to on score timer timeout, and let's update the score. HUD.update score and pass in the score. With that out of the way, we need to go back up to our ready function and go ahead and just switch this new game function over to pass because we don't want the game to start off automatically anymore. Now when we play the game, I'm going to hit F6 and we have our UI. Hit start. It's going to give us a little bit and the game starts just like that. Your score goes up over time, and if you hit a creep, you will get a game over screen. There's some unintended behavior still in the game where mobs do not get cleared when you start a new game. So let's go ahead and get rid of those now. I'm going to hit Control-Shift-O so I can open a scene, and then I'm going to select the mob scene. From here in the mob scene, go ahead and select the root node and then click the node tab next to the inspector. But instead of using signals, we're going to go to groups. And then we're going to create a new group. Go ahead and hit +sign. I'm just going to make this a global group. Let's name this one mobs, and for description, let's put mobs. Hit OK. Now, because we had mobs selected in the scene, now all of our mobs will be in the mobs global group. Go back to main and open up its script. I left clicked on the little script icon here. And in the new game function, let's go ahead and add a new line. Type in get tree.all group. We're looking for the mobs group. And on that group, we're going to call queueFree. What this does is it basically calls this method on all the nodes within this group. So this will cause them to delete themselves. Now our game's basically done, but let's go ahead and tweak a couple of things and make it a little bit nicer. Underneath main, go ahead and add a new node. We're going to use a color rect. Basically what we'll be doing is just changing the background color. Let's put this underneath main so it gets rendered behind everything else. Now this one only has one property. Go back to the inspector and we can change the color now. I'll left click that. I know I like this color, so I'm putting that in there. Now we're going to go down to layout, anchors preset, and we're going to go ahead and use full rect so that it covers the whole screen. Let's go back and actually look at it. There you go. I'm going to turn these off so you can see a little easier. If you wanted to use a texture or like an image instead of using a color rect, you can use a texture rect. Now let's add some sound. With main selected, let's add two nodes. We're going to use the audio stream player node just by itself, not the audio stream player 2D node. And let's duplicate that with Control D. Let's name one of them music and then the other one death sound. For music, we'll click on the stream property, do a quick load, and we'll just add in house and a forest loop for music. And then for death sound, do the same thing, quick load, and we'll just do game over. Now, if you want the music to loop seamlessly, go ahead and click on the music node and then look to the right underneath the audio stream player properties. You're going to go to this arrow and then hit make unique. Then click on the stream file resource itself and set loop to on. From there, we need to go back to the main node script, and underneath new game, we need to add some stuff. I'm just going to go ahead and add it right here in between. So I'm going to hit enter, Control Shift enter, and then get a reference to the music node, and then I'm going to type play. And now under game over, we're going to do something similar. I'm going to take music, hit stop, then death sound, play. And that's it. The last thing we're going to add here is a little shortcut to start the game. So from here, go to project settings. Under input map, hit add new action. And we'll call this one start game. I'm going to hit enter next to the plus sign. I'm going to click that. I'm going to hit the enter key on my keyboard. Hit OK. And then I'm going to hit close. Now from here, we can either click on this to open this in the editor like that. You could also have hit Control-Shift-O to open the HUD like that. Here, select the start button. And then if you look to the right in its dock, go down to where it says shortcut. Left click on that. Let's create a new shortcut resource, just like that. Left click on that. And then you are going to have to click on this array right there. Let's add an element to it. From there, I know this is a lot of steps just to get one shortcut. Go over to this resource, click on the arrow, and then create a new input event action right there. I went ahead and made this a little bit wider so you can see it easier. So the action itself needs to be start game right there. So let's save this. So altogether, it should look just like this. Make sure it's start game. You don't need any of these other things. Don't try to run it from here because it won't work. It'll just do that. You do need to go back to your main scene. And if you want to run this, hit F6. You'll notice the color. And then from here, you just hit enter on the keyboard and it's going to start. Hopefully it's not too loud. And that's it. Your game is done. If you had any questions or issues, please leave me a comment. I'll get right back to you. Hopefully this was helpful. In the next video, we'll be going over the first 3D project. Thank you for watching. Goodbye.